Welcome to this session. This session will solve a problem on how to determine inverse of a matrix by elementary operations or elementary transformations. So please write the problem. So let's solve the problem. So solution. So when you're asked to use elementary operations to find inverse of a matrix, you rewrite another matrix of the form AI, such that A is the matrix given, I is identity matrix of the same order as A, and then use row operations to reduce this matrix in the form that this position of A becomes an identity matrix, and this position of identity matrix is another matrix P, and then this matrix that you obtain as P is the inverse of this original matrix. So let's demonstrate on this specific case. So this will be our A matrix is 0, 1, 1, minus 1. And then we have 2, 1, 2, 1, 1, minus 1, 0, 2, 3, minus 2, 1, 6. Separated by a straight line. You can make it solid or dotted, there's no problem. And then identity matrix, because these are 4 by 4 matrix, so you write an identity matrix of order 4. So this is the first step. So the objective will be to use row operations to reduce these parts to be the identity matrix, and therefore the matrix that will come into this position will be the inverse of A. Now, the first thing that you see is that this matrix here, the element here is 0. And remember, the identity requires that this element be 1. So what we'll do, we'll switch or interchange the 2 rows of the first, we'll interchange the 2 first rows. So say row 1 to be switched with row 2. So row 2 is switched with row 1, and say row 3 to be row 3, row 4 to remain to be row 4. So by that switching, we will have an equivalent matrix 2, 1, 1, minus 1, minus 2, 0, 1, 0, 0, 0, 2, 1, 3, 1, 0, 0, 0, 1, 2, 0, 1, 0, 0, 1, 0, negative 1, 1, 2, 6, 0, 0, 0, 1. So that is the first step. We have interchanged row 1 and row 2 so that we have 1 in this position. Now we expect this to be 0, this to be 0. So we achieve that one by saying, let's now keep row 1 to be row 1, row 2 because we expect this to be 0, then at this step, let it remain to be row 2. But row 3, we expect this to be 0, so we'll say row 3 plus minus 1, row 1, and row 4 will be row 4 plus positive 1, row 1, so that we get 0 here and 0 here. So this transformation gives us an equivalent matrix 1, 1, negative 1, negative 2, 0, 1, 0, 0, 0, 2, 1, 3, 1, 0, 0, 0. Now this is the same as row 3 minus row 1. So 1 minus 1 is 0, 2 minus 1 is 1, 0 minus minus 1 is 1, 1 minus minus 2 is 3, 1 minus 0 is 1, 0 minus, okay, 0 minus 0 is 0, 0 minus 1 is minus 1, 1 minus 0 is 1, 0 minus 0 is 0, minus 1 plus, this one is plus, this will give us 0, this will be 2, this will be 1, this will be 4, the sum here will be 0, this will be 1, 0, and 1. So that's what we have. So this position is now fine. Now we expect this position to be 1. So we can say, because we can see a 1 here, let's switch the roles of row 3 and row 4, doesn't affect the operations. So say row 1 to be row 1, and then row 2 to be switched with row 3, and row 3 to be switched with row 2, and then we keep row 4 as row 4. So that one will give an equivalent matrix 1, 1, minus 1, minus 2, 0, 1, 0, 0. So here we have 0, 1, 1, 3, 0, negative 1, 1, 0. Now 0, 2, 1, 3, 1, 0, 0, 0, and 0, 2, 1, 4, 0, 1, 0, 1. Now we expect this to be 0, so we'll say row 1 to be row 1, row 2 to be row 2, but then now we use row 2 to correct row 3 and row 4, so we say row 2, row 3 to be row 3 plus minus 2 row 2, and then row 4 to be row 4 plus minus 2 row 2, so that we get an equivalent matrix 1, 1, minus 1, minus 2, 0, 1, 0, 0, 0, 1, 1, 3, 0, minus 1, 1, 0. Now 0, this same as 2 minus 2 times this is 0. 1 minus 2 times this is minus 1. 3 minus 2 times this is minus 3. This will be 1. And then this will be 0 minus minus will be plus 2. And then 0 minus 2. And then 0. 0 minus 0, 0, 0. 1 minus 2 times 1 is minus 1. 4 minus 2 times 3 is minus 2. This will be 0. 1 plus 2 is 3. This is 0 minus 1 is, so minus 1 times 2, minus 2. And then here we have 1. So that is the new matrix we have. So we expect this position to be -1. So expect this position to be 1. So we can multiply, say, row 1 to be row 1, row 2 to be row 2, row 3 to be -1 times row 3, row 4, let it be row 4. So that we have equivalent matrix 1, 1, minus 1, minus 2, 0, 1, 0, 0, 0, 1, 1, 3, 0, -1, and then 1, 0, 0, 0, 1, 3, -1, -2, 2, 0, 0, 0, -1, -2, 0, 3, minus 2, 1. Now, so we say row 1 to be row 1, row 2 to be row 2, row 3 to be row 3, and row 4 to be row 4 plus row 3. So that now we get 0 here. So we get an equivalent matrix 1, 1, minus 1, minus 2, 0, 1, 0, 0, 0, 1, 1, 3, 0, minus 1, 1, 0, 0, 0, 1, 3, minus 1, minus 2, 2, 0, 0, 0, 0, this will be 1, and then -1, this will be 1, this will be 0, this will be 1. Now, so at least we have now the upper triangular matrix now, but we expect this to be 0, 0, 0, 0, 0, 0, 0. So we'll say row 1 to be row 1 plus twice row 3, so that now I get 0 here. Row 2 to be row 2 minus 3, row, this is row 4, plus minus 3 row 4, so I'm saying that to achieve 0 here, I'll have to say row 1 to be row 1 plus twice row 4, and row 2 to get 0 here, I'll say row 2 plus minus 3 row 4, and then row 3 should be row 3 plus minus 3 row 4, and row 4 to remain to be row 4. So this will give us an equivalent matrix of, now we have row 1 plus 2, row 4. So this will be 1, 1 minus 1, 0. And then 0 plus 2 times minus 1 is minus 2. And then 1 plus 2 times 1 is 3. 0 plus 2 times 0 is 0. 0 plus 2 times 1 is 2. And then 0, 1, 1, 0. Now 0 minus 3 times minus 1 is 3, positive. And minus 1 plus minus 3 times 1. So this will be minus 3 minus 1 is minus 4. 1 plus minus 3 times 0 is 1. 0 plus minus 3 times 1 is minus 3. And then 0, 0, 1. This will be 0. And then minus 1 times minus plus minus 3 times minus 1 is minus 1 plus 3, which is 2. Minus 2 plus minus 3 times 1 is minus 5. And then 2. And then 0 plus minus 3 times 1 is minus 3. So 2 minus 5, 2 minus 3. Row 4 is 0, 0, 0, 1, minus 1, 1, 0, 1. So we expect this one to be 0, this also to be 0. So we'll say row 1 to be row 1. Now we are using row 3 now to correct that. Plus row 3. Row 2 should be row 2. Now this plus, so it should be minus row 3. Row 3 is in the correct form. And row 4 is in the correct form, so remains to be row 4. So that one takes us to an equivalent matrix, 1, 1, minus 1, 0. Okay, so just a minute. So we're saying to get the values in row 1, it is row 1 plus row 3. So 1 plus 0 is 1, 1 plus 0 is 1, minus 1 plus 1 is 0, 0 plus 0 is 0, minus 2 plus 2 is 0, and then 3 plus minus 5 is minus 2, 0 plus 3 plus 2 is 2, 2 plus minus 3 is minus 1. That's what we have. And row 2 minus row 3. So 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 0 is 0, 3 minus 2 is 1, minus 4 minus minus 5 is 1, 1 minus 2 is minus 1, minus 3 minus minus 3 is 0. And then row 3 is 0, 0, 1, 0, 2 minus 5, 2 minus 3, 0, 0, 0, 1, minus 1, 1, 0, 1. So this is the only problem. If we correct this position here, then we'll have an identity matrix on the left. So we'll say row 1 to be row 1 minus row 2. Row 2 is now in the correct form, so row 2 remains to be row 2. Row 3 is in the correct form, remains to be row 3. Row 4 is in the correct form, remains row 4. So this will transform into an equivalent matrix. So 1, minus 0 is 1, 1 minus 1 is 0, 0 minus 0, 0, 0 minus 0, 0, 0 minus 1 is minus 1, minus 2 minus 1 is minus 3, minus 2 minus 1 is positive 3, minus 1 minus 0 is minus 1. This is 0, 1, 0, 0, 1, 1 minus 1, 0, 0, 0, 1, 0, 2 minus 5, 2 minus 3, 0, 0, 0, 1, minus 1, 1, 0, 1. So that's what we have. Now, since now this is an identity matrix, so this is our P matrix, and this means A inverse, which is the same as P, is this matrix: minus 1, minus 3, 3, minus 1, 1, 1, minus 1, 0, 2, minus 5, 2, minus 3, minus 1, 1, 0, 1. So therefore, the inverse of the matrix is minus 1, minus 3, 3, minus 1, 1, 1, minus 1, 0, 2, minus 5, 2, minus 3, minus 1, 1, 0, 1. So that is how we solve that problem. Thank you.